We're going to try to predict how many UFO sightings are reported based on population of the city in thousands, what percent of the people live in rural areas, in other words, that live away from the city, and number of cubic feet of water. Okay, so this guy is assuming that it depends on how big a city is people wise, what percent of the people living in the country, and how much water a place has, and that all will predict how many UFO sightings are going to be reported. So let's go to our data sheet, take a look. There it is. Go to data, data analysis. Again, it's a regression. Click OK. And what's the DV? The DV is this guy, right? And the IV, the input range, you're going to highlight all three of the IV columns. And I want to put it where I can see it, H5, and I don't want the rest of that stuff. And I'm going to click OK. There it is. Give me 1 second. And I've cleaned it up for you. So I'm looking at the R squared. It's 0.44. That's a fair size model, right? In other words, 44% of the variance you can explain by this model. It is a significant regression model, so that means at least one of the predictors is good at predicting. Not all, but at least one. That's what this means. And so we're looking at the coefficients and the p-values of each of the predictors. So population, population, the p-value is greater than 0.05. So therefore, population is not a good predictor of UFO sightings. Percent of rural is, right? The p-value is less than 0.05. So the percent of the people that live in the country is a good predictor of UFO sightings, and the amount of water is not, again, because that p-value is way bigger than 0.05. So I think we have enough information. Let's go back to our questions. Okay, null hypothesis states that there's no regression. Nothing predicts anything. So the DV, the criterion, is UFO sightings. The IV is population in thousands, the percent living in rural areas, and a number of cubic feet of water. And it is a significant regression. The ANOVA tells us so. Because it was less than 0.05, that means it's a significant regression. And we can explain 44%, that's your R squared, your effect size. So was population a good predictor of UFO sightings? No. Right? Because the p-value is greater than 0.05. Rural percentage of residents? Yes. In fact, that was the only significant predictor. Open water sources? No. So there was only one significant predictor, then that makes it the strongest, and that's rural percent of residents. So the prediction equation is, let's go back and get our data points from the output here. Again, to write your coefficients, to write your prediction model, you need the coefficients from the ANOVA table, not the standardized, the unstandardized, but Excel doesn't do standardized, so just the coefficients. Okay, so again, we're going to use the intercept. That's the same thing as a constant. So from the coefficient box, we know we're only going to use one of them, and that's the rural, right? Because that's the only one that was significant. So we're going to have a short equation line. Let's get back to the answer sheet. So your predicted equation is simply going to be the coefficient for rural, which was 1.59, plus the intercept value. Okay? So the last question is, if we have a population of 172,000 people, which doesn't make a difference. That's why this number is not in the final prediction equation. 22% of the residents is, because that's the rural thing. That's the only thing that's significant. So that's the value we put in here. And the cubic feet of water, again, that's not in the equation. So if you plug in 0.22 for X1, you simply get around 14. And that's it. MGZ.